Hello and welcome back. This is a section in Unit 8, and this is Section 5. We're going to start the introduction of three-dimensional figures and cross-sections. So the first thing we want to do is we want to be able to classify a 3D figure and identify the characteristics of that 3D figure, like a base and an edge. And we want to determine the horizontal and vertical cross-sections of 3D figures. We also want to determine the 3D figure generated by rotating a two-dimensional figure. So we'll kind of talk about that later. All right, so let's first talk about what a prism is. And this is not to be confused with the word prison, okay? Which is where bad people go. And you guys aren't bad, you guys are good, so let's not go there. All right, so a prism is a three-dimensional solid whose bases are two parallel congruent polygon bases and whose other faces are parallelograms. Yuck. Okay, so basically, you have this idea of a base, okay? And I like to kind of think of a triangular prism, okay, of like your base, and your faces are these parallelograms that go up from the base. So I'm going to outline the bottom down here, okay, as your base, okay? And I'm going to outline this part here as your base, okay? And your base shape is typically your bottom shape, depending on how the figure is oriented. But it also depends on how it's named, okay? So like if you say a triangular prism, a triangle is your base, okay? And same thing over here with a rectangular prism, okay? This bottom part over here, all right, and this top part are your base, okay? Those are bases, all right? And that's kind of how we name the shape, all right? That's where we have the base, okay? Now, a face, when I talk about a face on a prism, this is a surface, okay? Now, it could be your, surface slash plane, okay? And, on something like this, you've got a bunch of different faces, okay? You have all these different rectangular faces, okay? The bases are included in that concept of what a face is, okay? Same thing with a triangular prism, okay? The bases, these triangles, are considered faces. So are the other sides that are on this, okay? All right, now the edges, all right, this is where the faces meet, okay? This is where the faces meet, okay? And I'm going to outline that in blue. I'm going to come over here. All of these different corners here, okay, is where these are all different edges, okay? So these are what we call edges, all right? And your bases, I'm going to color the base in red, okay? So we kind of understand the difference between a base. Make sure we can see that. Okay. All these different parts here are edges. All right. But the bases are the top and bottom parts. Okay. Same thing over here. Let me color in my bases real quick so we know what those are. So the bases are colored in, but the edges are not. All right, the edges are where these surfaces meet, okay? Okay, so the edges are in that area too. Okay, and then we have vertices, okay? And a vertice is where the edges meet, okay? So a vertice is where the edges meet, okay? And I'm going to color those in orange. I'm going to come over here. I'm going to kind of plot points at which all of this occurs. Okay, all those different points, these are all different vertices. Okay, I'm going to do the same thing over here. All right, all these different spots have different vertices. Okay, so I'm going to name those over here as vertices. All right, so just getting some of these names down, knowing what they are, and all that. So the most important thing about this, guys, I think, is identifying what your base is. And remember, it depends on how it's named. Okay, now we also have another figure type, and that is a pyramid. Okay, so a pyramid is a three-dimensional shape, three-dimensional solid whose base is a polygon. So I'm going to color in the bases real quick. Okay, just so we have those. All right. And so we have a rectangular pyramid, and that kind of tells me what type of pyramid, tells me what the base is. And we have over here a triangular pyramid. Okay. And that allows me to see what my base is. All right, kind of tells me what it is. All right, now we have certain surfaces. Okay, and surfaces are different, parts here that make this up. And so, we have a base who is a polygon, but the sides of a pyramid are triangles that meet at a common point. Okay, so we also have edges. Okay, when we talk about pyramids, all right, and that's where all your faces meet, all right, and that's all these different parts here. These are all edges, all right, same thing over here, all right, and so there you got those. Okay, so these are edges. Okay, you also have vertices, okay, in a rectangle or in pyramids, okay, but there are these bottom parts here, okay, these are vertices, okay. However, vertices, if you can read that, sorry. However, we also have this thing called an apex, and the apex is the top of the pyramid, okay. And so these 2 points here, top of the pyramid, we're going to call that the apex of the pyramid. Okay, so we've got those as well. So we're going to study, introducing a lot of different 3D shapes. We've got prisms that we see. We also have pyramids, and we'll talk about some more on the next page. But before we do that, I want to talk about this idea called a 3D cross-section, or cross-section of a 3D shape. Okay. And I'm going to kind of import a little video into here and kind of show you something about those 3D shapes and kind of how we get those. Okay, and so what I notice, this is a video I just found on YouTube, and it's called Komi Pottery. Okay, Komi Pottery. And so they use this idea of a cross-section where they take these pieces of clay and they cut them, and the resulting surface has a shape on it, okay, and has these different designs, okay, and so it's kind of cool stuff, actually. I found this on the Facebooks, but they they cut this, and then they pull that back, and the resulting shapes is what you see, okay, and that's what we call a cross-section, okay. It's kind of like slicing bread is kind of how I think of it. This is really cool how they use this, and then they take those clay pieces and they make pottery out of it. So pretty unique. So geometry is everywhere, and don't ever forget that. So we have these cross sections, okay? And so it's that same idea. If you were to take a wire or something like that and cut a three-dimensional shape, a cross section is the two-dimensional shape that occurs from cutting a three-dimensional figure. So let's write that down. Let's write that a cross-section is a two-dimensional shape that is created by slicing a 3D shape. Okay. All right, so now, if over here, and it's kind of like we're going to have either horizontal cross sections, which are go side to side, or we're going to have vertical cross sections, which go up and down. So, this shape right here is what's created from the cross section. Okay, and we want to identify what kind of shape we get by slicing that three-dimensional figure. So this two-dimensional shape would be, and let's just call it a square for now, square slash parallelogram. Okay. If I were to do the same thing on a triangular prism, do a vertical cross section, this would give me a triangle. Okay. And it's all about your ability to name these cross sections. Okay, if I took a pyramid and I did a horizontal cross section, okay, this shape right here, this would give me a rectangle. Okay. All right, let's go down over here. If we did a vertical cross section on a pyramid, though, that would give us a triangle. Okay, so pretty cool stuff. Triangle. All right, over here, if we took a triangular prism and did a vertical cross section on it, the resulting shape would be a rectangle. Okay, a rectangle. Okay, same thing over here, and I think, did we already have one of these? Yeah, we already did. All right, so it kind of depends. And what I want you to see here, especially on this like triangular prism, is that depending on the cross section that you do, you're going to get different shapes. Okay, if you did a vertical cross section here on a triangle, you can cut it in a way that gives you a triangle, but you can also cut that triangular prism in a way that you'll get a rectangle out of it. So it's important that we know what those are. Okay, on this next page, we're going to talk about how we obtain the concept of a cylinder and or cone. Okay, so a cylinder is, like a soda pop can or something like that, and then a cone is like an ice cream cone, like a waffle cone. Okay, all right, so I'm going to show you guys how we actually rotate these shapes, and what we're going to do is we're going to take these two-dimensional figures and we're going to rotate them around these different axes to kind of determine what kind of shape we get. So I'm going to show you an animation for that. Okay, so if I were to rotate these parts around here, what's created and what you can see is you get these cylinders if you rotate around. Okay, the same thing happens down here. If you rotate these figures, these triangles around these axes, okay, then you're going to get a cone. Okay, and so that's what's going to happen there. And so when you rotate those around, and that's how we get a lot of these interesting shapes, is by revolving a surface around an axis. Okay, and so that's the idea. All right, so, what we end up happening here is we end up getting, these two different shapes. Okay, one is a cylinder, the other is a cone. And the difference between a cylinder and a cone, a cylinder has two parallel congruent circular bases. Okay, so the base here is, a circle. Okay, just like these down over here. Okay, so they all have a similar congruent circular base. All right, and then you have the base is here and here. Okay, now the difference between that and a cone is that you have one circular base, okay, but then you have that on all of these different ones, okay. You have all those different circular bases, but each of them has an apex, okay, and the apex is the very, very top Okay, so a cylinder is kind of similar to like a prism, and a cone is kind of similar to a pyramid. It's just that we have rounded surfaces. So let's go ahead and kind of talk about what a cross section would look like, okay, on certain pieces. So if you did a cross section of a cylinder, okay, a horizontal cross section, you would end up getting a circle for your cross section. Okay. However, if you did a vertical cross section of a cylinder, that's going to give you a rectangle. Okay, so you get these different shapes. Okay, depending on how you cut them. Okay, if you do a horizontal cross section of a, you're going to get a circle if you do a horizontal cross section of a pyramid. Okay. But if you do a vertical cross section of a pyramid, you're going to end up getting a triangle out of this. Okay, so kind of unique and different. All right, the last 3D shape I want to introduce to you is a sphere, which is also a movie starring Samuel L. Jackson, Dustin Hoffman, and somebody else. It was kind of an interesting movie. I want to say that it's rated PG-13. So you guys should all be able to watch it. It's a good movie. It was made in 1998, starring Dustin Hoffman, has Samuel L. Jackson, and then Sharon Stone. Brrr. She was, yeah, I think she's an attractive woman. Okay, so that's what I've got. So a sphere, okay, is kind of an interesting thing. A sphere is a circle that's actually been rotated around an axis, if you want to classify it that way. But a sphere is a set of all points in a space given from a given distance from a fixed point. So you have this center of a pyramid. Okay, you have a center of a pyramid, and you have this great circle. Okay, and this is the largest cross section you can get. Okay. If you were to do any sort of cross section on a sphere, you would get a circle. But the one where you're going to have the great circle is the one where you have the largest cross section. Okay, so kind of a cool thing. So that's all I've got for this video. Hope you enjoyed all the different things that we had in it. So gonna go ahead and name what you go through the assignment and go through the quiz and see how you do. So thanks. See ya. Bye.